study links Apollo astronauts to cardiovascular deaths. A new study reports that Apollo astronauts have experienced elevated rates of cardiovascular-related deaths, likely because of exposure to deep space radiation, as evidenced by the launchpad fire that killed 3 members of the Apollo 1 mission and the near disaster of Apollo 13. The elite astronauts selected for NASA's Apollo program risked their lives in the quest to land the first man on the moon. Now, a new study asserts that even those Apollo astronauts who splashed down safely on their return to Earth may have suffered adverse effects on their long-term health from their deep space travel. A view of the Earth appears over the lunar horizon as the Apollo 11 command module comes into view. Credit: NASA, newsmakers. The Apollo program, which began in 1961, sent 9 flights into deep space beyond the Earth's orbit between 1968 and 1972, including the Apollo 11 mission in July 1969 in which Neil Armstrong became the first man to set foot on the moon. According to a paper published today in the journal Scientific Reports, Apollo lunar astronauts have suffered cardiovascular-related deaths at a rate 4 times higher than those of astronauts who remained in low orbit and 5 times higher than astronauts who went through training but never took flight. Although the Apollo astronauts were of a similar age to other astronauts, there was one significant difference. They are the only humans to have been in deep space. All the other astronauts stay in low Earth orbit, says Michael Delp, a professor and dean of Florida State University's College of Human Sciences, who conducted the study along with a NASA-affiliated team of researchers. As I started looking initially just reading obituaries and biographies, it looked like the lunar astronauts were dying at a higher rate than either the low Earth orbit astronauts or non-flight astronauts. To study why the Apollo astronauts, although highly educated, physically fit and subject to top medical care, suffered higher rates of cardiovascular-related deaths than even the general public, the researchers considered both the direct effects of space radiation and weightlessness. The research team studied the impact of simulated weightlessness and irradiation on the vascular systems of mice. While the simulated weightlessness had little impact, the mice exposed to radiation demonstrated impaired arteries known to lead to cardiovascular disease in humans. What the mouse data show is that deep space radiation is harmful to vascular health, Delp says. We know very little about the effects of deep space radiation on human health, particularly on the cardiovascular system. This gives us the first glimpse into its adverse effects on humans. A shadow-shrouded Neil Armstrong, first man to walk on the moon, begins to deploy equipment a few minutes after taking the first momentous and historic step. Credit: Bedman. The study's authors point to exposure to galactic cosmic radiation in deep space as the likely cause of the elevated instances of heart disease because exposure to charged particles has the potential to elicit a number of complications in biological tissue. The 24 Apollo lunar astronauts were the only humans to travel beyond the protection of both the Earth's atmosphere and magnetosphere, which protects the planet by deflecting damaging galactic cosmic rays and highly charged solar particles. By passing through the Van Allen radiation belts, the Apollo astronauts were exposed to levels of galactic cosmic radiation not experienced by any other astronauts or cosmonauts. The researchers acknowledged the limitations of their study, in particular the small sample size. Of the 24 men who flew into deep space on the Apollo lunar missions, 8 have died, and the study only included 7 because Apollo 14 veteran Edgar Mitchell passed away earlier this year after the data analysis had been completed. In addition, the doses given to the laboratory mice to mimic deep space travel were higher than those experienced by the Apollo lunar astronauts, crew of Apollo 11. Credit: NASA. Since the study claims that even short-duration deep space travel by astronauts results in a significantly elevated risk of death from cardiovascular disease, the study has particular relevance to plans by various governments and private enterprises to send manned missions to the moon and beyond. Russia, China and the European Space Agency are considering the possibility of manned lunar missions, while NASA plans for orbital missions around the moon between 2020 and 2030 as a preparatory step to a manned mission to Mars. SpaceX founder Elon Musk has proposed getting there even earlier by landing humans on Mars by 2026. A mission to Mars would require approximately 6 months of space travel each way, far lengthier than the Apollo missions, which ranged between 6 and 12 days in their totalities and expose astronauts to deep space radiation far beyond anything experienced by the Apollo spacemen. Going forward, what we're interested in is finding out and examining ways we might counteract this radiation effect, particularly on the blood vessels, says Delp, who adds that examining measures to minimize the oxidant stress on blood vessels might counteract the effect of deep space radiation.